These are the currents notes, talking about the ocean currents and how things move around in the ocean. Ocean currents involve large water masses and are any continuous flow of water along a broad path in the ocean. There are two types of currents. There are surface currents and deep currents. Of course, surface is going to be at the top, and the deep currents are going to be what goes down low towards the bottom of the ocean. And then taking a look at this picture here, we've got wind blowing the surface, just like when we talked about with tides and waves. The wind is blowing on the surface, moving the water in a certain direction. And then when it gets to the poles, North Pole, South Pole, it's going to get cold. And when it gets cold, it's going to sink because it's more dense. And then it gets to the bottom. It's still very, very cold. It talks about being deep right there. And then as it gets down towards the equator, it heats back up. And we know that makes the water become less dense. So then it rises to the surface where it gets heated up. And then it's going to get blown back towards the poles where it cools down, sinks because it becomes more dense, and then it's a whole big cycle. Surface currents. A surface current is an ocean current that generally flows in the upper 1,000 meters of the ocean. This type of current is created by wind, because remember, wind happens above the water, so that's what's going to push around the water at the surface. Surface currents in the northern hemisphere turn clockwise, and in the southern hemisphere turn counterclockwise. This is going to be really important for you to know. And of course, keep in mind, maybe you've heard about if you go to Australia and you flush the toilet, the water turns the other way. This is exactly what it's demonstrating here, because in the northern hemisphere, you flush the toilet, it turns clockwise, right? Well, if you go to somewhere in the southern hemisphere, it actually turns the other way and turns counterclockwise. Currents that flow away from the equator carry warm water, and that makes sense because at the equator it's hotter, so the water is going to warm up. And currents that flow toward the equator carry cold water because when they're at the poles, it's going to get cold. Earth's rotation and presence of continents influence the paths of currents, but surface currents are mainly caused by wind. The Coriolis effect is the apparent deflection of winds due to the rotation of the Earth. And this happens to the right in the northern hemisphere and to the left in the southern hemisphere. Essentially what this is if you think about maybe the U.S. wants to bomb another country on the other side of the world. If they're going to send a missile from here to the other side of the world, they have to take into account the fact that while that missile is in the air, the Earth is spinning underneath of that missile that's up in the air. And if we don't take that into account, we're going to miss the target. So you had to factor in the Earth spinning. And with this Coriolis effect, as the Earth spins, if something's traveling in the northern hemisphere, it's going to get deflected or sort of moved to the right. And if it's in the southern hemisphere, it gets deflected to the left. And then the trade winds. Talking about the winds, which hopefully you guys have heard of before, at least maybe in social studies. Trade winds and westerly winds form most ocean currents, and you can see where they happen right here around the equator. The trade winds blow from the northeast in the northern hemisphere and the southeast in the southern hemisphere. Taking a look at the arrows, you can see that it's those directions. The westerlies blow from southwest in the northern hemisphere. Here we go. And the northwest in the southern hemisphere. And then if we look here at this picture, imagine this is, let's say, the Atlantic Ocean. And then we have North America over here, and we have Europe and Africa over here. So if you're in the northern hemisphere, here's the equator, that's 0 degrees. The winds, the trade winds, are blowing to the left. And then when the winds and the water hit North America over here, it diverts the winds and the water and push it back as the prevailing westerlies in the direction of Europe. and then it hits Europe over here, and then goes back along the equator, and then it does the opposite way in the southern hemisphere. It goes along the equator, that would be hitting South America there, and then diverting over here, and then back over towards Africa. There are different types of surface currents. Warm currents flow away from the equator. We already talked about this. And an example would be the Gulf Stream in the North Atlantic. The water gets warmed up in the Gulf of Mexico and then comes up in the Atlantic past us. Cold currents flow toward the equator, like the California current in the North Pacific. It's bringing that cold water to the equator because once it gets cold, it wants to get warm. It's kind of like you. When you get cold, you'd rather warm up. And then when you get warm, you want to be cooler. So once your temperature changes, you want to move to someplace where your temperature is going to be able to change back. The Gulf Stream rings are eddies or whirlpools that break away from the edge of a current and sort of make its own thing. And counter currents flow in the opposite direction of the wind-related currents, and this happens along the equator. Now the currents below the surface. These currents are driven by gravity and differences in density. A density current is heavier and denser than the surrounding water. So think about the lab that we did where we colored the water, the different colors. This is what we're talking about. When we had the colder, more dense, more salty water, it's going to sink to the bottom, and that's what kind of drives these currents. These currents sink toward the bottom of the ocean where they circulate for 500 to 2,000 years before they resurface again down at the equator. And these happen in all four of the oceans. Density currents from the polar water. The most dense water comes from the poles because it's going to be cold and it's going to be saltier because of the ice. There are three main water masses: the Antarctic bottom water, the North Atlantic deep water, and the Antarctic intermediate water. And just as a reference, the Antarctic bottom water is the coldest, densest water at negative 0.4 degrees Celsius. And remember, in a previous video, I talked about how it's possible for the water to be colder than the freezing point, because when you add in that salt, it's actually going to lower the freezing temperature. And then density currents that are caused by evaporation. When seawater evaporates, salt in the water is left behind, increasing both the salinity and therefore the density of the remaining water. Because when the water gets evaporated, the salt is staying. An example of this is in the Mediterranean Sea. Water there is very dense because it's hot around the Mediterranean, so the fresh water is getting evaporated back up into the water cycle. The salt stays behind, making the water more dense. We talked about this again when we did the density lab with the water, where we colored the water at the beginning of the unit. And then taking a look here at this picture for upwelling. You're going to need to adjust your picture a little bit because the arrows don't come out on the picture. So you need the wind stress vector to be drawn on your paper, which you can kind of see it there, but you got to fill in the key up here at the top. So make it somehow where you can see that this arrow that you see on your notes is the same as the wind stress vector there. Maybe just draw a line, draw an arrow, whatever you want to do. And then this blue arrow that's pointing away from the shore is called the Ekman transport vector, which is what's pushing the water out of the way. And then the upwelling vector, the dark blue, which you can see, is where the deep cold water rises up to the surface. So the definition of upwelling is a kind of vertical current. It occurs when surface water is displaced by winds or density currents. The cold, deep water rises to replace the surface water. So if you think about the wind is going to blow, it's pushing the water on the surface out of the way, which leaves room for this cold, deep water to rise up to the surface. Water that upwells is very nutrient rich. These become very productive areas for plants to grow. The plants make a great place for animals to migrate. And we're actually going to discuss how upwelling off the coast of Peru attracts a whole bunch of life at the time when the upwelling occurs during the year.